Hi students, here now I am going to give you the solutions of monthly test 2 for only numerical part. I will start the session. First question, they are telling n identical resistors, that means R, R, R and so on, R, that equivalent resistance they are telling X, it should be R plus R plus R plus and so on n. I can write it as X equal to NR, that is equation number 1. Then the second case they are telling all identical resistance they are going to place in parallel. Like this. Then the resultant they said Y, that is 1 by R equivalent equal to, or else 1 by Y equal to 1 by R plus 1 by R plus and so on 1 by R. It should be N by R. Then Y equal to R by N. This is equation number 2. Now you simplify these two equations, you will get X by Y equal to NR divided by R by N. Here R cancel, X by Y equal to N square X equal to NR, Y equal to R by N. Then X by Y equal to N square, then X equal to N square Y. Then your answer should be option D. See what is it? Effective resistance between the 2 points when they are in series, R plus R plus R plus and so on n times. That n times I am writing NR, that is X equal to NR. The next case, 1 by Y is the equivalent resistance, 1 by equivalent resistance equal to 1 by R plus 1 by R plus n times. This is n by R. Then Y equal to R by N. Simplify these two equations, X equal to N square Y. Clear? Next, I am moving to the second question. In the second question, they gave like this: 1 ohm, 2 ohm, 1 ohm, this is 2 ohm, again this is 1 ohm, 1 ohm, 2 ohm, 2 ohm, 1 ohm, 1 ohm, 2 ohm, 2 ohm. They connected like this. They are asking to find what is the effective resistance between the 2 points and resistivity. See, very simple thing. Resistivity is the depending on the nature of the material. Here entire the material remains the same. Material is not going to change. Then resistivity remains the same. Resistivity remains same. Why? Because material is not going to change. Then your answer should be rho only. Now coming to the equivalent resistance. See here, this 1 ohm and 1 ohm series, that I will replace with the 2 ohm, and this 2 ohm and 2 ohm series, it should be replaced with the 4 ohm. They have this common point. Then again 1 ohm and 1 ohm series, which is 2 ohm, and then this is 2 and 2, 4 ohm. Again 1 and 1, 2 ohm, 2 and 2 series, 4 ohm. Now here what is the equivalent resistance for the 2 and 4? These 2 and 4 both are parallel. For parallel combination, 2 into 4 by 2 plus 4 is the equivalent. That is 8 by 6, which is 4 by 3. That means I will replace the circuit. This is 1 4 by 3. This is also 4 by 3. Why? Because that is also for parallel 2 and 4. Again here it is 4 by 3. These all are in series. Then equivalent will be 4 by 3 plus 4 by 3 plus 4 by 3, which is 3 times of 4 by 3, which is 4 ohm. Then your option again, fourth option 4 ohm and row, option D. See, in this manner we have to solve the circuits. Simplify. Next, the third question, work done to rotate an electric dipole from unstable equilibrium to stable equilibrium. What is the position for unstable equilibrium? You all knows about the dipole minus q plus q, whatever it is, length let it be some 2a. Electric field is like this. Now unstable equilibrium means unstable equilibrium, that condition potential energy should be maximum, which is potential energy is maximum means PE minus PE cos theta. Theta should be 180 degrees. Then potential energy will be PE cos 180 degrees, which is PE. Cos 180 is minus 1. That's why. Once again, let me tell you the position of unstable equilibrium. Unstable equilibrium means theta should be 180 degrees, like this, minus q plus q. This is the dipole moment direction, p bar, but electric field is like this. What is the angle between p bar and e bar? P bar is like this, e bar is opposite direction, then theta is 180. This is unstable equilibrium. I'll say theta 1 initial. Then what is stable equilibrium? Stable equilibrium means potential energy will be minimum. Potential energy minimum means U equal to minus PE cos 0 degrees, which is minus P. Here theta equal to 0 degrees. That means P bar, dipole moment and electric field both should be same direction. This is E bar. Like this. Here P bar and E bar both are same direction. Now there is a equation, work done to rotate the dipole. Work done to rotate the dipole. Work done to rotate the dipole formula PE into cos theta 1 minus cos theta 2. What is here cos theta 1? Initially it is unstable equilibrium. Unstable equilibrium, which is theta 1 is 180 degrees. Cos 180 degrees minus cos stable equilibrium final, that is theta 2 0. Now PE cos 180 is minus 1, cos 0 is 1, minus 2P. See, most of the students you write that 2P. That is not correct. Here sign convention is very important. Sign convention is very important. Unstable to stable minus 2PE, stable to unstable plus 2PE. Then your answer should be, oh, this is anyhow, this is like not MCQ type. Your answer is minus 2p. I hope it is clear. Initially unstable equilibrium, theta 1 is 180, and finally stable equilibrium, theta 2 is 0. Then work done equal to P into cos theta 1 minus cos theta 2. Then substitute the values, you will get it. Next, fourth question, already I sent you the answer. Fifth question also already I sent you the answer in a WhatsApp group. Sixth one is direct question, you can do. And seventh question, I'll try to do it. Seventh question, determine the electrostatic potential energy of a system consisting of 7 microcoulomb and 2 microcoulomb. Okay, this is the question. Okay, you read the question. Before doing the question, you read the question from your question paper. Here, 7 microcoulomb and minus 2 microcoulomb are placed at minus 9 centimeter, 0 plus 9 centimeter, 0. Here it is 7 microcoulomb. Here it is minus 2 microcoulomb. They are asking to find what is the potential energy of the system. Potential energy of the system equal to 1 by 4 pi epsilon naught Q1 Q2 by R. 1 by 4 pi epsilon naught is 9 into 10 power 9. Q1 is a 7 into 10 power minus 6. Why? Because micro. Minus 2 into 10 power minus 6. Distance between minus 9 to plus 9. Total length from minus 9 to plus 9 centimeter up to here 9 centimeter. This is 9 centimeter. Total length is 18 centimeter. Now 9 into 7 into minus 2 into 10 power 9 minus 6 minus 6, 18 into 10 power minus 2 meter. All you have to convert into SI units. Now 9 2s are 18 gets cancelled, which is minus 7 into 10 power 9 minus 12 plus 2. This 10 power minus 2 will become 10 plus 2. You will get minus 0.7 joule. The question, what is the potential? What is the first question? Determine the electrostatic potential energy. Electrostatic potential energy is minus 0.7 joule. Now coming to the second question. Just first question is like a simply the substitution. U equal to 1 by 4 pi epsilon Q1 Q2 by R is the potential energy. And second question, how much work is required to separate two charges infinity away from each other? Initially both are at here. Finally, this is the situation. Now I am going to take both into infinity. This to infinity, this to infinity. When two charges you take into infinity, final potential energy should be 0. And initial potential energy already you calculated. How much? Minus 0.7 joule. Then work done equal to final potential energy minus initial potential energy. Final is 0 minus 0.7 joule, which is plus 0.7 joule. In this manner we can calculate. Clear? Work done equal to final potential energy minus initial potential energy. Now coming to the C question. What would be the here the same system they placed in a electric field equal to A by R square like this, where A also mentioned A equal to 9 into 10 power 5 some coulomb per meter square. What would be the electrostatic potential energy of this configuration? This configuration means like this. This is origin, minus 9, 0, 7 microcoulomb, plus 9, 0, minus 2 microcoulomb. In this kind of situation, how to solve? The electrostatic potential energy is potential energy due to their positions, that is q into v1 plus q2 into v2 plus, and the interaction energy is 1 by 4 pi epsilon naught q1 q2 by r. See, first one is due to their orientation. Q1 charge, let it be, this is Q1. Potential at this point is V1. This is Q2 and potential at this point is V2. Then 1 by 4 pi epsilon naught Q1 Q2 by R. Now, Q1 relation between V and E, they didn't mention V anywhere. How to relate potential and electric field? V equal to E into T or E into R. V equal to E into R. Then V1 should be equal to E into R1. V2 equal to E into R2. Then substitute, students. V equal to Q1. V1 is E into R1 plus Q2 into V2 is E into R2 plus 1 by 4 pi epsilon Q1 Q2 by. No need to calculate. This one already is calculated in the first question. 1 by 4 pi epsilon Q1 Q2 by R is, you got minus 0.7 joule. Q1 is A by R1 square into R1. Q2 is A by R2 square into R2 minus 0.7 joule. Here R1 square, R1 gets cancelled, R2 square, R2 gets cancelled. Next page. U equal to Q1 into E1 by R1 plus Q2 into E by R2 minus 0.7 joule. Sorry students, here it is not E, it is A by R1, A by R2. A value you know, Q value you know. Q is 7 into 10 power minus 6, A is 9 into 10 power, it is mentioned in the question, 9 into 10 power 5. R1 is 9 into 10 power minus 2 meter, 9 centimeter. Q2 is minus 2 into 10 power minus 6. A is 9 into 10 power 5. This is also 9 centimeter from the origin. If you simplify this one, you will get the answer. This is your textbook question, example question. You take the, I think 43.9 or 49.3 something your answer. You just check it after simplification. See, major thing you need to remember, whenever the system of charges placed in the electric field, then what is the potential energy? Potential energy is due to individual charges Q1V1 plus U2V2 plus interaction energy. This is called interaction energy between two charges. 1 by 4 pi epsilon Q1 Q2 by, it is already calculated. And V is here. V1 is E1 R1. V2 is E2 R2. E1 is A by R1 square. V2 is A by R2 square, that given in the question. Okay. Yes. Next. Wait a minute, students. Hello. Yes, ma'am. 42 now. Okay. Okay, ma'am. Okay. That Akshara Kumar also going to take TC. She applied. Okay, students. Let's come back to the question number 8. Question number 8, sub question. 8, first question, it is, difference between EMF and terminal potential difference, that you but no need to discuss now. Next, see, a storage battery EMF 8 volt and have the internal resistance 0.5 ohm being charged by 120 volt DC supply having internal resistance 15.5 ohm. Now this is the question given in, they didn't mention the diagram, but you need to picturize this one. What is the terminal voltage of the battery during the charging? Terminal voltage of the battery during the charging. That means terminal voltage means from this battery, this point. See here I am mentioning with the red point. Potential difference between A and B they are asking. That is called terminal velocity of the battery. Whatever it may be, let it be. First you find what is the current coming from the source. I'll say this is I, this will be I, this is also I. Okay, now you can use the Kirchhoff rule also, like Kirchhoff rules. Here I'll go like this. I'll give the names and then I'll give the loop name also, A, B, C, D. I'll use the loop A, B, C, D, A. Directly I can tell, but if you have doubt, you follow this method also. You are going from A to B. A to B means higher terminal to lower terminal, which is minus 8 volt, and your current direction and resistance loop direction same, minus 0.5 I. And coming to C2, C2D, there 15.5 is there, and current direction also same, minus 15.5 I. And lower terminal to, minus 2 plus 120 equal to 0. That is 120 minus 8 equal to 16I. Why? Because 15 0.5I and this one. I'll send the other side 16. 117 equal to 16I. I equal to 117 by 16. 16 7s are 7 ampere current. It should be 7 ampere current. Alternate method also I will give you. Here I equal to E equivalent by R plus R. This is capital R. This is small r. Alternate. If you feel that it is difficult with Kirchhoff rule, you use this one. I equal to E by R plus R. Here E equivalent is 120 minus 8 by 15.5 plus same thing you'll get. I equal to 112 by 16, 7 ampere. Once you find the I, they are asking to find what is the potential difference between A to B. It is the condition for charging battery. See here, this I is entering towards the positive terminal. This is charging method. E plus IR. EMF is 8, current is 7, resistance is 0.5. 8 into 7 into 0.5 is 3.5, which is 11.5 volt. Students, first you need to find the current, then potential difference between A and B is the terminal voltage. Terminal voltage is charging method, E plus IR. Discharging means E minus IR. Anyhow, this is charging, E plus IR. I hope it is clear. I am moving to the next question. See the question number 9. In the question number 9, first differentiate between the polar and the non-polar, that you know already. Define the dielectric constant with the medium, that is also you know, and units, no units. and derive the expression for the capacitance of a capacitor in between. That means C equal to, I think many of the students didn't try this one. See, from battery pen charge get over. Just meanwhile you see the previous question how I did. Just a minute, let me charge my pen. Yes, see the question number 9. See, 9th, derive the expression for the capacitance of a capacitor with the dielectric in between. That means they are asking to find C equal to epsilon naught A by T minus T plus T by K, or C equal to K epsilon naught A by T. This you need to derive. I think they didn't mention how much thickness, then maybe that is the according to your question here given, that is okay. This is the situation. C equal to K epsilon naught A by D. This they are expecting to derive. C1 equal to K epsilon naught A by D. And second case they mentioned this is K1, this is K2. Here they use like this. This distance between them is D. I will say this is they mentioned this length is L by 2, this length L by 2. Then area also, this is A by 2, this is area A by 2. Here C1 equal to epsilon naught. Instead of epsilon naught, K1 epsilon naught A by 2, area distance is D, which is K1 epsilon naught A by 2D. C2 equal to, C2 means this one. I'll say this is C1, this is, or else I will say this is C1, C dash, C double dash. C double dash means this one. I'll say this is C dash, this is C double dash. C double dash equal to K2 epsilon naught. This is also having area A by 2, distance D. K2 epsilon naught A by 2D. But both are in parallel. This C dash and C double dash parallel. Then it should be C dash plus C double dash. K1 plus K2 by 2 is common. Epsilon naught A by D. After adding these two, you will get this result. I am writing a bit for a quick manner. See, C dash and C double dash both are in parallel. In this manner I calculated. And in question they gave one if clause. What is the if clause given? See if C1 equal to C2, what is the relation between K and K1, K2? C1 is K epsilon naught A by D. C2 is K1 plus K2 by 2 into epsilon naught A by D. Epsilon naught A by D, epsilon naught A by D cancel. K equal to K1 plus K2 by 2, which is 2K equal to K1 plus K2. Okay, in this manner we will calculate. Once again check this derivation from the textbook. Already I gave this one in the notebook. From classwork you go through it. And this is the method how to find the equivalent capacitance between this system. C dash, C double dash. Then total CP is the C2. C2 is C dash plus C double dash. Why? Because both are in parallel. And they mentioned if class C1 equal to C2, what will happen? That is the relation. And coming to ninth question, alternate. They gave one more option. Choice. Ninth question, second choice. This second choice, they are asking to find the relation of energy Q square by 2C derivation, or else energy density U equal to half epsilon naught E square, this derivation. Apart from this, many of the students they made the mistake about this question. That question is, draw the graph between capacitance of the capacitor and the charge given to it. C equal to Q by V. Students will confuse C is proportional to Q. Most of the students drawn C versus Q graph is like this. But as per the properties of capacitance independent of charge given. See students, be patient and go through all the problems what I explained. C equal to Q by V, capacitance of the capacitor is independent of charge given to it. Then whatever the charge you give, capacitance will be fixed. Then that means C won't change with the Q. Then the graph will be like this. And the one more question they're asking. This is X capacitor, this is Y capacitor. Here one plus minus connected like this. They're asking to find what is the relation between energy of X and energy of Y. What energy of X, I'll say Ux. Energy of Y is Uy. What is the relation between these two? That is my question. See, whenever this kind of questions are there, better you take the relation U equal to Q square by 2C, or half QV or half CV square. You choose the equation in such a way that maximum constants are there. Here Q is there, V I don't know, V whether constant or not. C I know, but V I don't know. Avoid the voltage terms. Voltage of this one I don't know. Maybe here V1 voltage, here V2 voltage. It is going to be complicated. See what I am telling. Here half QV or half CV square. In these both the cases voltage depends, but I don't know what is the voltage drop across V2, I mean V1 here and here. Then better you avoid this equation. I am not going for it. I am going for this one. But in series I know charge remains same. Here charge Q, here also charge Q. Okay. Here charge Q is there, suppose. Here also charge Q will be there in a series combination. Then in this Q is constant, 2 constant, U is inversely proportional to C. Then I will write Ux by Uy equal to Cy by Cx. Cy is the capacitance in air, epsilon naught A by D. Capacitance when it is in with the dielectric, 6 epsilon naught A by D. Because it is with the dielectric, 6 epsilon naught A by D. Epsilon naught A by D, epsilon naught A by D cancelled. Ux by Uy equal to 1 by 6. This is your answer relation. Check it once how I did. First one, Q square by Tc derivation you know. This energy density also I mentioned, but this is a bit tricky. Students will make the mistake. Capacitance is independent of charge given to it. Then it is like this. And third one, in this combination they are asking to find the relation of energy stored in the X and energy stored in the Y, and which formula we need to take. Better you avoid the voltage relation. Why? Because here charge remains the same. Charge and capacitance relation Q square by 2C. Q is constant, U is inversely proportional to C. Ux by Uy equal to Cy by Cx. Capacitance you know, epsilon naught A by D for in air. In a medium, K epsilon naught A by D 1 by 6. In this way we can calculate. Now coming to the last question. First I'll start with the second part, Kirchhoff rules part. See, whenever these kind of questions, if they mention the current direction, you don't take your current direction. According to you, you don't take. Whatever they mentioned in the question, you take the same thing. Here they mention this is I1, this is I2, this is I, and again here I2, here it is I1, like this. I'll give the names A, B, P, Q. Now how to solve this one? A, B, P, Q, loop given. They're asking to find currents. I1 you need to find, I2 you need to find, I3 also you need to find. Also the potential difference across 8 ohm. For this what I'll do? First I'll take the loop A, B, A, B, Y, X, A. Loop A, B, Y, X, A. See, I'll do a bit fast. A to B. A to B you are going in the path of A to B, one 10 volt battery is there, plus 2 minus you are going, that means potential drop minus 10, and current is coming towards left, your motion is towards right, current is coming B to A, but you are going A to B, minus 1 into I1, then B to Y no element is there, but Y to, like this, I2 current is there, same direction of your loop, sorry, minus 10, this will be plus 1 I1, why? Because current direction, your loop direction opposite, you are going like this, current opposite direction plus I1, but coming to this 1 ohm, here current is coming Y to X, your motion loop direction also Y to X only, minus I1, minus I2, and you are coming from minus 2 plus, which is 8, equal to 0. That means I1 minus I2 minus 2 equal to 0. I1 minus I2 equal to 2. This is equation number 1. I will take one more loop, which is A, B, Q, P, A. Loop A, B, Q, P, A. That means outer edge. A to B minus 10. This is plus 1 I1. B to Q nothing, but you are coming from like this, but opposite direction. current direction is opposite, plus 8I equal to 0. Then I will write this is I1 plus 8I equal to 10, equation number 2. But you have unknown variables I1, I2, I3. But you got only two equations, equation number 1, equation number 2. But you have one more equation. By using the junction law, what is the junction law at A? I1 entering, I2 entering, it should be equal to I. Sorry, this is not I3, I1 plus I2 equal to I. As per the junction law, I1 plus I2 equal to I at A. Now I will write I1 minus I2 equal to 2, equation 1. I1 plus 8I equal to 10. This is equation 2. Simplify these three equations and you will get I1, I2, I. If you get I1 and I2, I should be I1 plus I2. And what is the potential difference across 8 ohm? Across 8 ohm in this question, current is I. Then potential difference I into 8, 8I. This I is I1 plus I2, substitute here. I'm not going to solve individually, but this is the way to solve. I don't say this is the only way, you can choose according to you. The last question. Again this question most of the students made mistake, that is Wheatstone bridge. Let me draw the diagram. Actually I am tired from the morning, I have the classes, but I am happy this is the last question. In the question I mentioned, in the Wheatstone bridge shown above, what would be the value of R1 and R2 in order to balance the bridge? See, to balance the bridge, this is the situation, like here somewhat galvanometer, here current in this should be 0. That means, but here they didn't give the galvanometer, something they gave. Something else they mentioned. Instead of galvanometer here, instead of galvanometer, this thing something they mention. You don't worry about this one. First you take the outer one. Outer one. This is here whatever may be that, forget about that one. Why? Because they are telling this is the balanced bridge condition. P by Q equal to R by S. P is a 10, Q is R1, 30 by 8. Cross multiply 10 into 8, 80 by R1 equal to 30. Gone. Somewhere I made mistake. This is not 8, this is 9 ohm. Then R1 should be 3 ohm. See, then if R1 is 3 ohm, this bridge is balanced. In this no current. In this no current. I will say these 2 points are equipotential points. Here I'll write like this. Equipotential points. Then only when potentials are equal, then only there is no current in this. Galvanometer current is 0. Bridge is balanced. When this is equipotential point, whatever may be the resistance exist here, whatever it may be, no problem. Why? Because no current in this, you can ignore this total element. You can ignore the total thing. You don't worry about this thing. You can ignore these elements, whatever the resistors present here. That's why R1 equal to 3 ohm. R2 can be any value. Whatever may be the value, we can ignore that one. No issue. That's why. But most of the students, again, they applied the Wheatstone bridge for the internal one. That is your mistake. Let me tell once again. Very clear the point. Here this point and this point are equipotential surfaces. For equipotential surfaces or else equipotential points, no current in this. That means we can ignore this circuit, internal circuit. This circuit means this internal circuit, whatever it is there, we can ignore that. Then R2 can be any value, whatever may be the value, it is balanced. That's it, students. If any doubts are there, you can call me back. Thank you.